All right, what we're working on today is an introduction to integers and making sure we understand what integers are. Integers are, it's just remember that a number can be classified as real, or as, rational, or irrational. And an irrational number is a number that just stops. It has an ending. An irrational number is a decimal, something like 0.3333 that keeps going. It doesn't have an ending point. It's irrational. There's also integers, but integers are positive and negative. Okay, integers can be graphed on a number line. The things that you should notice about a number line is that zero's in the middle and all the negative numbers are on the left and all the positive numbers are on the right. And as you get farther away from zero, the larger the number gets. So even though usually going to the right, the number the larger gets, it's still the same thing. Even though to the left they're getting more negative, these are actually getting smaller. So bigger numbers are on the right, smaller numbers are on the left. All right, there's several things you're going to have to be able to do today. One of them is being able to write things in ascending order. Okay, for ascending order, numbers go, ascending is like you ascend the mountain. They go from small to big. So they go from smallest numbers to biggest numbers. And then descending numbers are the opposite. They go down. And so these are numbers that go from the highest to down, like going down a mountain. And so these are from biggest numbers to smallest numbers. Okay? So if I had a list of numbers 2, -3, 5, -7, and I wanted to go ascending, I would pick my smallest number, which is my number farthest to the left. So my smallest number is -7. And then my next smallest number would be at -3. And then my next smallest number would be at 2. And then at 5. So this would be ascending order. If we wanted to go descending, descending is just opposite of that. So my biggest number is 5, then 2, so I go from right to left this time, then -3, then -7. Okay? All right, so why don't you go to your left side and let's try these 4 problems here. Once you have them done, then you can press play to check your work. Make sure that you are writing the problem down. It's not helpful if you just write down the answer. Okay, so you should all be done with this one. So ascending is from small to big. So my smallest number is -6, then -3, then 1, then 2, then 5. I really recommend you either underlining or maybe crossing it off after you've done it, because sometimes you'll forget numbers if you don't do that. All right, for number 2, my smallest number, my number farthest to the left was -2.5, and then -1, and then 0.4, 3, and then 4. For the next one, descending, remember, is going down, so I look for my biggest number. So for number 3, your biggest number was 7, and then 5, and then 1, 0, and again, remember the numbers, they go from right to left for descending, so my number closest to 0 is -2, and negative 3. And if you ever get confused in that, go up and look at your number line. Make sure you understand how it works. Negative 2 came before negative 5, so that's why it was before that. Okay, so for number 4, this might have been tricky for you. Hopefully you put this as a decimal. And so now it's easier to see. So my biggest number was 3. And then came the 2.5, which is 5 over 2. And then came the 2. And then the negative 1.5 and the negative 3. So even though we're done with fractions and decimals, you still have to be able to understand how to get them there. Okay. All right, let's look at our next part of notes. So the next two things we have to do is we have to use inequalities. We have to be able to do the less than and the greater than. So remember, for less than, your inequality points to the smaller number. So if I have 5 and 7, it points to the 5. That says less than. Negative 3 and 1, it points to the negative 3. Negative 7 and negative 5, it points to the negative 7. Because again, smallest numbers are farthest on the left of your number line. Okay, so they get smaller to the left, bigger to the right. Okay, greater than, it's open at the larger number. So this time, 8 and 6, it's open at the bigger one here. There's this wide opening right there. And so that's why it's greater than, okay? 1 is greater than anything to the left of it. So if we pick a number to the left of it, maybe negative 2. And then negative 3 is greater than anything to the left of it. So maybe negative 8. Now, greater than is open at the bigger number, but if you notice, it still points to the smaller number, right? That's what I said happens. It points to the smaller number, and it is still pointing to the smaller number. Okay, so let's go down and do some more examples on your left. So go ahead and copy these problems down, and when you think you have them, go ahead and push play so that you can check your work. Okay, I went ahead and drew a number line just in case people needed it. So 2 and 5. 2 is farther to the left, so it's less than. Then I'm going to change colors. Negative 3 and positive 4. Negative 3 is farther to the left, so it's less than. Negative 2 and negative 5. Negative 5 smaller than to the left, so I pointed to the negative 5, so it actually says greater than. And then my last one, negative 4 and negative 3. Negative 4 is more to the left, so it's less than again. So again, if you need your number line, draw a quick number line, and whichever one is farther to the left, that's the one that it points to. Whichever one is at the left, that's where the point's at. All right, the last thing that we have to talk about today is absolute value. And the absolute value is the distance a value is from 0. Oops. Okay, so I have my number line. Let's do the absolute value of 2 and the absolute value of negative 2. And so I'm going to highlight where 2 is. 2's right here. And it's also negative 2's right here. If I counted how far away it is 1, 2 away from 0. So the absolute value of negative 2 is 2. And it is 2 away from 0 here also. So the absolute value of 2 is 2. So whenever you take the absolute value, it becomes positive. And the reason that happens is even if I walk right or left, I still have a positive value. Okay, I still have a positive distance. Walking steps, you can't have negative distances. You're still traveling even if you go backwards. So a lot of times people remember that absolute value is always positive. Okay? Now, there's some situations where they're not positive, and situations like that are when it's on the outside. So if I have an absolute value of 4 here, inside is positive 4, but you'd have to bring out the negative because it was in front. So if there's a negative in front, it can still stay negative, and what is inside becomes positive. Okay, so we're just going to have some simple problems with absolute value, and just remember it's always positive. So go ahead and write these down and see what you can do, and then press play when you think you got it. All right, so for number 2, I just take the absolute value of negative 2, which is positive 2. For number 10, the absolute value of 10 is positive 10. For problems like 11 and 12, it's kind of a two-step problem. I first have to find the absolute value of 5, which is 5. Bring down my plus sign, and the absolute value of negative 3, which is 3. 5 plus 3 is 8, and that's my answer. For number 12, it's the same thing. The absolute value of negative 15 is 15, minus the absolute value of 3, which is 3. 15 minus 3 is 12. Okay. All right, so remember, smallest numbers are on the left, bigger numbers are on the right. For inequalities, they point to the smaller number. Absolute value is always positive, and when ascending, you go up, and descending, you go down.